Hello guys, and welcome to the second video on linear algebra. So we're going to use Gauss-Jordan method to find the inverse of a matrix A given by 2, 4, 3. We now have 1, 3 and 4, then negative 1, 3, 6. Now the traditional way of finding the inverse of a matrix, I believe you're all familiar with the traditional way of finding the inverse of a matrix. That's A inverse is equal to the adjoint of A divided by the determinant of what? A, whereby the adjoint of the matrix A is actually the cofactors of A transpose and divided by the determinant of A. So this is a very canonical approach of finding the inverse of a matrix, and trust me, as the matrix order begins to grow, so this is a 3 by 3 matrix, or we can say A belongs to R3 by 3. Okay, so as the order of the matrix begins to grow, you will discover that this method is not applicable. It's time consuming and it is just not it. Okay, it's not just applicable. So what is the remedy? Now we have what we call the Gauss-Jordan method. The Gauss-Jordan method is just synonymous, or it is analogous to what we call reduced row echelon form. Okay, so Gauss-Jordan method. Now we have reduced row echelon form and we have what we call the row echelon form. So if you can be able to convert a system of equations to what we call row echelon form, you are performing Gaussian elimination on that system. Okay, so I take it again, if you can reduce a system of a matrix, you can reduce it to row echelon form, you have performed Gaussian elimination. But if you go further to reduce that system to reduced row echelon form, you take it a step from row echelon form to reduced row echelon form, you have performed Gauss-Jordan elimination on that system. And Gauss-Jordan elimination method is very important. It helps us to solve for system of equations, and it also helps us to compute the inverse of a particular matrix. So the process is easy. All you just need to do is to be familiar with Gauss-Jordan elimination, or and your elementary row operations. Sorry about that. Now from my experience in solving this particular kind of questions, you're going to solve for the inverse of this particular problem in about 7 to 9 steps. Okay, 7 to 9 steps is all it takes to solve for the inverse of this particular problem. Now this is how we are going to develop the inverse of this problem. Okay, so we are going to develop a matrix C, okay, such that that matrix is actually formed when you augment your A matrix with an identity matrix. Okay, so when you perform elementary row operation on this particular matrix and you take it to what we call reduced row echelon form. Okay, so if you perform reduced row echelon form, in the process of performing that reduced row echelon form on this matrix, you will see that this identity matrix, your identity matrix, will also belong to your n by n system. That means if A is an n by n matrix, then you have an n by n identity matrix. If A is 2 by 2, I will be 2 by 2. If A is 3 by 3, I will be 3 by 3. So in the process of performing reduced row echelon, okay, on this particular matrix A, you discover that your identity matrix will gradually convert to the inverse of A. Okay, and that is where you will now extract the inverse of A. Now let's dive in. So we are going to have this matrix like this. We'll form our augmented matrix C in this way. So we have 2, 4, 3. Sorry about that. 2, 4, 3. Okay, and we now have what's it next? 1, 3, 4. 1, 3, 4, and now have minus 1, 3, 6. Okay, so I'm going to append it with an n by n identity matrix. So in this case, it's a 3 by 3 identity matrix. So you have 1 0 0, you have 0 1 0, and you now have 0 0 1. So this is step 1. Okay, step 1. Now after that, you now perform what we call what? Of course, the reduced row echelon matrix. So remember that we want to make sure that our reduced row echelon matrix, we're actually focusing on this guy over here. Okay, so anything that we perform here will affect this guy, and gradually this guy will convert to our inverse. So I want to make sure that my this matrix, okay, the goal is to convert this particular side to something like this: 1 0 0 0 1 0 and 0 0 1. So immediately I do that conversion, then I'll have some a b c d e f g h i. So this a b c d e f g h i will constitute the inverse of a. Okay, so your goal is to convert everything here to 1 0 0 0 1 0 and 0 0 1. So this is a reduced row echelon form. As you can see, the first element in every row is 1, and all other elements below that leading one is 0. In the second row, the first element is 1, the element below is what? 0, and the element above is 0. Very good. And the last row, the elements, the first non-zero element is 1, and all entries above it must be 0. So this is what we call reduced row echelon form. So let's quickly dive in and see how we're gonna implement that. So let me just take this one out. Okay, so let's dive in. So what do we do first of all? I can see a 1 here, so I can swap. So I can swap my row 2. So swapping row 2 with row 1. So this is the symbol for swapping. Okay, so if you want to swap row 2 with row 1, you write it like this, an arrow pointed in both directions. So that will now give me something like this. So row 1 will become row 2, and row 2 will become row 1. So row 1 becomes row 2, 2 4 3, and you have your 1 0 0. Okay, row 3 stays as it is, minus 1 3 6, and you now have 0 0 1. Now row 2 will now become row 1. You have your 1 3 4, and you now have your 0 1 0. Are we good with that step? So the next step is, since we've gotten 1 here, we'll now find a way to convert this to 0. So follow me. How do I convert this to 0, and how do I convert this to 0? So it's very easy. So the new row 2 will be what? The former row 2 minus 2 row 1. Similarly, if I want to convert this particular point to 0, I know that minus 1 plus 1 is 0. So I can just say the new row 3 will be what? The former row 3 plus row 1. Take note, the operations to get this 2 to 0 are performed with reference to what? Row 1. Is that okay? So every other thing will just fall in line. So let's dive in and see how it goes. So row 1 stays as it is, 1 3 4. Then you have your what? 0 1 0. So this is where we begin to convert what? Row 2. So row 2 minus 2 row 1. 2 minus 2 times 1 is what? 0. So that's 2 minus 2, 0. Okay, so I'll advise you that when you're solving this problem, please have your calculator close to you, because you might run into fractions and you might not want to waste your time performing fractions. So just have your calculator close to you, and it will help with accuracy. Okay, so 4 minus, so anyone I cannot solve, I'll just write it by the side. Anyone I can't solve with my head, I'll write it by the side. 4 minus 2 times 3. Okay, 2 times 3, that's a 4 minus 6, which is a negative 2. So you can see this element has converted to 0 like we wanted. So every other thing here will just fall in line. So 3 minus, okay, 3 minus 2 times 4, 3 minus 8 is a negative 5. Okay, then you have 1 minus 2 times 0. 1 minus 0 is going to give you 1. Then you now have 0 minus, be careful here, you have a 1 here, so you have 0 minus 2 times 1. So that is a -2, and 0 minus 0 is 0. Okay, so we'll repeat the same thing in row 3. So the new row 3 will be the old row 3 plus row 1. So -1 plus 1 will give you what? 0. Okay, so you've converted it to 0. So 3 plus 3 will give you 6. 6 plus 4 gives you 10. 0 plus 0 gives you 0. 0 plus 1 gives you 1, and 1 plus 0 gives you 1. Okay, so we are actually making progress. So what's the next thing? So the next target is this particular element here. Okay, the next target is this particular element here. So first of all, we need to find a way to convert this particular element here to what? Very good, we need to convert it to 1. Okay, remember our target is the 1 1 1 0 0 0 0 0 0, like this. Okay, so we need to convert this element here to 1. So how do we do that? So we can perform row operation on this particular one. We can say the new row 2 should be the old row 2 multiplied by what? Minus half. So minus half times what? The old row 2. Okay, so we multiply every entry in the old row 2 by minus half. So if we do that, then this is what we're going to get. So we're going to get 1 3 4, now have 0 1 0. Row 3 stays as it is, 0 6 10. You have 0 1 1. So multiplying every entry by half. Okay, 0 times minus half is 0. Minus 2 times minus half is going to give me 1, like this. Okay, 5 times minus half is going to give you what? Very good, 5 over 2. Take note of the sign, minus minus is plus. So 1 times minus half is going to give you -1 over 2. Okay, take it carefully and gradually. 2 times minus half is going to give you exactly 1, just like this one. So, and 0 times minus half is going to give you 0. Okay, so what's next? Now that you've converted this one to 1, you need to what? Convert this one to 0. Remember, all elements under the leading ones should be converted to 0. So how do we convert this particular element to 0? You can see that the dimensions of row 2 and row 3 are now the same. So if I want to convert this element here to 0, I'll make reference to what? Row 2 from row 3, in the sense that I'll say my new row 3 will be my old row 3 and minus 6 row 1. Remember, this has a coefficient of 6. So to make it cancel out, you need to multiply this one by a number that will make it cancel out. So row 3 minus what? This is row 2, I'm sorry about that, minus 6 row 2. So let's see what happens if we do that. So we're going to have, as it stands, row 1 and 2 will remain as it is, 1 3 4, and you now have 0 1 0, and you now have 0 1, 5 over 2, -1 over 2, 1 0, you now have 0. Okay, so before I write this 0, row 3 minus 6 row 2, so you have 0 minus 6 times 0, which is 0. So you now have 6 minus 6 times 1, which is what? 6 minus 6, which is 0. So you now have 10 minus 6 times 5 over 2. 10 minus 6 into 5 over 2. That is 10 minus 2 here, 1, 2 here, 3. And 3 times 5 is 15, which is -5. Okay, -5 here. Are we together? So in this place you have 0 minus, take note, 0 minus minus, 0 minus minus, okay, 0 minus minus, which is 0 plus, is that okay? 0 plus 6 into 1 over 2, which is going to give you a 3, is that okay? And you now have 1 minus 6 times 1, that's 1 minus 6 times this guy, which is going to give you -5, and you now have 1 minus 6 times 0, which is going to give you 1. Is that okay? So in doing like this, we have successfully converted our system to this form where the leading 1 in the second row has an element of 0 under it. So the next target is this guy over here. You now want to convert it to what? 1. Okay, remember all the diagonals should be 1. So how do you do that? Very easy. You can see your new row 3 is actually -1 all over 5 of the old row 3. So you're just dividing through by -5 basically. Is that not true? So we are now going to actually do that. So you can see that before I do any row operation, I have to write this down. It's very important so that you know what to do. So you have your 1, 3, 4, then you now have 0, 1, 0. You now have 0, 1, 5 over 2. Then you now have -1 over 2, 1, 0. And you now have dividing every entry by -5. 0 divided by -5, 0, 0 minus 5 divided by -5 gives you 1 exactly. So you now have 3 divided by -5 is -3 over 5, or simply 3 times -1 over 5 gives you -3 over 5. So -5 and -5 again, it will give you 1 like this. Then 1 divided by -5 is going to give you -1 over 5. Is that okay? So you have converted all the leading ones, all the leading elements to 1. So the next thing is to now jump to this point. How do I convert here to 0? Remember, we started with this and we went to this and this like that till we found this diagonal. And once you're done with this diagonal, you have to take it to what? Reduced row echelon form. In this form, 1, 1, 1, 0, 0, 0, 0, 0, 0. Okay, you need to find an upper triangular matrix of 0. So we'll convert everything here to 0. So we are going to start with this one over here. So how do we convert this particular 1 to 0? So to convert this 1 to 0, you can see that the only position that can influence this 3 is this one. That is why you're going to mix row 1 and row 2 like this. You're going to say your new row 1 is equal to your old row 1. How do you convert this one to 0? Okay, since this is a 3, you need to multiply this guy by 3 so that when you subtract it, it will be 0. So old row 1 minus 3 times row 2. Is that okay? So that's what we're going to do now. So let's dive in. So in doing it like that, you're going to have 1. Okay, sorry, I'm not going to write it right away. Remember, in doing this change, only row 1 is changing. So row 2 and row 3 will remain as they are. -1 over 2, 1, 0. You have 0, 0, 1, -3 over 5, 1, and -1 over 5. Now let's find what the new row 1 will be. The new row 1 is subtracting each entry in row 1 from 3 times the corresponding multiple in row 2. So 1 minus 3 times 0 is still going to be 1, because 3 times 0 is 0 and 1 minus 0 is 0. Now 3 minus 3 times 1 over here is going to give you 3 minus 3, which is 0. So we have successfully converted this guy to 0. Remember, that was our main target. So every other thing will fall in line. The effect of targeting this guy influences the value of other positions, so you don't have to worry about that as far as you get what you wanted to get. So 4, you need to write this one down. 4 minus 3 into 5 over 2. So you can see that to do this particular one, you have 4 minus 15 over 2, which is still the same thing as 8 over 2 minus 15 over 2, which is going to be -7 over 2. Okay, so -7 over 2. So 4 minus 3 into 5 over 2 gives me -7 over 2. So you're going to do 0 minus minus. Okay, so 0 minus 3 into 1 over 2, which is 0 plus 3 into 1 over 2, which is 0 plus 3 over 2, and which is a 3 over 2. Is that okay? So you do 1 minus 3 times 1, which is 1 minus 3, which is -2. Then finally you do 0 minus 3 times 0, which is going to be 0. Is that okay? So you do it carefully, one by one, one by one. Now that we've done it like this, what is remaining? What is remaining? So we need to convert this guy to 0, and finally this guy to 0. So which one do we start with? We can start with anyone we want. Okay, I want to convert this guy to 0. Okay, I want to convert this man over here to 0 first. So if I want to convert this man to 0, see, this position matches with this position, so I'm going to combine row 1 and row 3 like this. So I'll say my new row 1, okay, my new row 1 is equal to my old row 1, okay. So you can see this is a minus 7 over 2, okay. So minus 7 over 2, and this is 1, so I can say old row 1 plus 7 over 2 row 3. Is that okay? So you're interfacing row 1, okay, with 7 over 2 row 3. Since this one is negative, then the positive aspect of this one will make this one to cancel out. So this is how it's going to work. So just follow me gradually in case you're lost. So you have every other row will stay the same, or we can also do 2 at once, and I can also change. Okay, I can change this one directly. I can change this one to 0 directly by saying the new row 2 is going to be the old row 2. Okay, since this is 5 over 2, I can say 5 over 2, the old row 2 minus 5 over 2 row 3. So this will now enforce that this term will be minus 5 over 2, so that when you do this minus this, it will be 0. Then other elements will take care of themselves, whatever this may give. So I'm doing 2 things at once. So the only thing that is not changing here is row 3. Row 3 is going to remain the way it is. Okay, row 3 is going to remain the way it is. Then every other thing will change. So row 3 is going to remain as 0, 0, 0, 1. Then I have minus 3 over 5, 1, minus 1 over 5. So this is row 3. So row 1 and row 2 are about to change. So let's start with row 1. So to start with row 1, we see that to get row 1, the new row 1, we need to say the old row 1 plus 7 over 2 row 3. Okay, so 1 plus 7 over 2 times 0 is still going to give you 1. Is that okay? Gradually, 0 plus 7 over 2 times 0 is also going to give you 0. Now, negative 7 over 2 plus 7 over 2 times 1 is going to give you 0, because these are counter magnitudes. One is negative and one is positive, so they will cancel out, which is what we wanted. We wanted here to be 0. Okay, so we'll go to this element over here. We now have something like a 3 over 2, then 3 over 2 plus 7 over 2 into minus 3 over 5. So we have to be careful. If you have your calculator, you could just easily run that one. So let me just use my calculator and save myself stress. So what we want to do is we want to do 3 over 2 plus 7 over 2 times minus 3 over 5. Okay, minus 3 over 5. So I have negative 3 over 5 there. That okay? So negative 3 over 5. So that is what will result in this particular point here. So when you do 3 over 2 minus plus 7 over 2 times this value, you get minus 3 over 5. Is that okay? So when you do minus 2 plus 7 over 2 times 1, so you discover that you can change this to minus 4 over 2 plus 7 over 2. minus 4 plus 7 is going to give you 3 over 2. So you have a 3 over 2 here. And finally, 0 minus 7 over 0 plus 7 over 2 into minus 1 over 5. So if you do the maths, you're going to get minus 7 over 10, because 0 plus 7 over 2 into minus 1 over 5 evaluates to what? 7 over 10. So we finished row 1. So we now want to do row 2. So to get the new row 2, the old row 2 minus 5 over 2 row 3. So 0 minus 5 over 2 times 0 will be what? 0. 1 minus 5 over 2 times 0 is going to be 1. So 5 over 2 minus 5 over 2 times 1 is going to give you 0. Okay, so this was the target, remember. So it's now 0. So we now have 0. So let's come to this point. We have to be careful from here. So we now want to solve okay, remember, row 2 minus 5 over 2 row 3. So we now have minus 1 over 2 minus what? Minus 1 over 2 minus 5 over 2 multiplied by what? Minus 3 over 5. So you can see the mathematics here. So this will be minus 1 over 2, then minus times minus is plus, and you now have 5 cancelling out 5, and you're now left with 3 over 2. So minus 1 over 2 plus 3 over 2 will give you what? 2 over 2, which is unity. So here is going to be what? 1. Is that okay? Here is going to be 1. So remember, minus 1 over 2, that's R2 minus 5 over 2 R3. So minus 1 over 2 minus 5 over 2 times this value will give you 1. So you now have 1 minus 5 over 2 into what? 1. So if you do the maths, you have 2 over 2 minus 5 over 2, which is negative 3 over 2. Is that okay? So you can put this one as negative 3 over 2. And you now have 0 minus 0 minus, there's already a minus. So this is the first minus and this is the second minus. Minus 5 over 2 into what? 1 over 5. So if you do the maths, to be 0 plus cancelling out, you have you have 1 over 2 left, right? So that's 1 over 2, like this. Is that okay? So at this point, well, what do you know? You have converted this particular place to reduced row echelon form. So this is in RREF, okay? And what is now obtainable here is your A inverse. Therefore, you can now say A inverse is equal to whatever we had here, which is minus 3 over 5, 1 minus 1 over 5. You have 1 negative 3 over 2, 1 over 2, and you now have negative 3 over 5, 3 over 2, and negative 7 over 10. So you can actually use your calculator to verify this, and you see that it's actually a very beautiful method of evaluating the inverse of a matrix. So this method requires patience, and remember to use your calculator, and remember to practice like 2 times before you go to the exam. Don't assume that you know it. You have to solve this question like 2 times at least, so that it will stick to your hand, because it might come out in the exams. So let's count how many steps we used. So we have 1, which was finding our augmented matrix. Then we now have the swapping of the row, which is step 2. Then we now have the first transformation, step 3. The second transformation in step 4. Then we now have the third in step 5. We have the fourth is 6th transformation, then 7 transformation, and now have what? 8. So like I said, earlier that it will take you 7 to 9 steps to solve this particular problem, and you can see we used only 8 steps before we now finally arrived at our answer in the 9th step. So if you do your work carefully in about 7 to 8 steps, you should win the full marks that is associated with this question. So if you have a scientific calculator, I'll advise you in exam scenarios, first of all, if you can find the inverse of a matrix on a scientific calculator, try to find it and keep it somewhere. Okay, use it as a reference, convert it to fractions if you can. Then when you now solve your problem, remember to use calculator to perform complex subtractions, like something like this. So just plug it in the calculator to evaluate it for you. So when you now do all those subtractions and so on and so forth, you should now compare your final answer with what is gotten on the inverse, and hopefully pray that you get the same thing. If you don't get the same thing, try to trace where you made a mistake and make the corrections. So I wish you all the best in this particular question. I hope you understand it now. If you don't understand it, please, you might need to review what we call elementary row operation so that you will understand how to do it. So this Gauss-Jordan Elimination Method of finding the inverse of a matrix, which is in other words known as the Reduced Row Echelon Form method. So thank you for watching. Like, subscribe, share, hit the notification bell to stay updated. So we are going to be solving more questions. Please stay tuned and watch out for the next video. Bye.